Welcome to this explainer. Today we are tackling something absolutely mind-blowing. We're looking at the incredibly audacious goal of treating planetary physics like a colossal DIY engineering project. We aren't just talking about taking a quick trip to visit another planet. We are talking about what it actually takes to resuscitate a totally dead world. So let's dive right into this blueprint and look at the real, hard physics, thermodynamics, and electromagnetism required to actually turn Mars into a second home for humanity. To truly wrap our heads around the sheer astronomical scale of this project, we first have to face the brutal reality of our as-is property. Because, before we can start building, we've got to look at what we're working with. And right now, Mars is a completely frozen wasteland with an average surface temperature of -62 degrees Celsius. It is harsh, it is unforgiving, and it is entirely hostile to human life. But we've got a plan. Here is our 5-phase game plan to pull this off. First, we'll diagnose the red desert problem. Then we calculate the planetary energy budget, trigger a greenhouse kickstart, deploy an artificial magnetosphere, and finally settle in for the long oxygenation wait.
All right, let's kick things off with phase 1, the red desert problem. Let's assess the damage.
To figure out exactly why Mars is currently a dead patient, stripped of its life-giving atmosphere, we really need to look at this stark comparison. Understanding its past is literally the only way we can engineer its future. On one side, you have Earth's thick, nitrogen-rich atmosphere, basically a cozy blanket that keeps our water liquid and our temperatures nice and stable. On the other side, Mars. The Martian atmosphere is roughly 100 times thinner than Earth's, and it's made almost entirely of carbon dioxide. It's barely a wisp of a planetary atmosphere. But why is it like this? Well, the root cause of this whole barren situation comes down to something called the geodynamo effect. This is the generation of a global magnetic field, and it's caused by the rotation and convection of a planet's molten core. Billions of years ago, Mars actually had a hot, active core, just like Earth does. But because Mars is so much smaller, that core eventually cooled down and solidified. And when that core froze, the geodynamo effect stopped completely, effectively shutting off the planet's global magnetic field.